Hello everyone. In today's video, we will be discussing about pdV work and VDP work. Now let us understand this pdV work and VDP work. pdV work or displacement work is applicable for a closed system, whereas VDP work is applicable for an open system. Now to understand pdV work, let us consider a closed system, or we refer it as a non-flow process because here there is no mass flow. Now in this closed system or piston cylinder arrangement, we have considered a working substance or a fluid. Now this working substance is undergoing a process, means initially it was at position 1 and then it has reached the position 2. Means the fluid has undergone an expansion process, and during this expansion process work can be extracted from the system. Now let us see how to quantify this work. During the stroke 1 to 2, consider the piston has reached a position and from there infinitesimal displacement of the piston has taken place. Let us consider it to be dl. First let us find the work for this dl displacement and then we can quantify for the entire expansion process 1 to 2. Since it is an infinitesimal displacement, so work done also will be very less. Let us consider it as dw. As we know, work done is force into displacement and dw is written as F into dl. Now to find force, force is nothing but the pressure exerted on the piston, say P, and area of the piston, say A. Now force can be written as pressure into area into this dl. Now area into displacement means volume. So this is also an infinitesimal volume swept by the piston. Now this can be written as P into dV. This work what we have got, it is for the small displacement dl. Now for entire displacement from 1 to 2, it can be written as the integral of dw, that is integral of pdv. From this equation we got that work done for the process 1 to 2 is integral of pdv. Now if we plot this on PV diagram, you can see here it is an expansion process 1 to 2 and the area under the curve is the work done. That means if we have an expansion process in a PV coordinate, you project the curve into x-axis, and if it is a non-flow process, then the area under the curve, this area, it is represents the work or pdv work. Now if it is a compression process, then same 2 to 1, we will be having the work, that is this area will be considered as the work which is to be given to the compressor. Now let us understand VDP work. As I told you earlier, the work undergone under an open system is called VDP work. So this is an open system or flow process. As you see here, there are two pipes. One is for fluid entering and the other is for fluid leaving the system. So the working substance is entering through this pipe and leaving through this pipe. This open system can be either compressor, turbine, nozzle, anything, any open system we can consider. Now let us apply the steady flow energy equation. Steady flow means there is no mass accumulation nor energy accumulation. Such a device is called steady flow device. Now we will assume heat energy is entering the system and work energy is leaving the system. If that is the case, then energy entering to the system will be equal to energy leaving the system. Now energy entering to the system means it will be the internal energy, flow work, kinetic energy, potential energy along with the heat energy. These are the energy which is entering the system. Same energy will be leaving the system along with the work extraction. So in the mathematical form, steady flow energy equation can be written in this way. Now this enthalpy is nothing but the summation of internal energy and the flow work, and this is the kinetic energy and potential energy, and along with this energies we have added the heat energy. Now this energy which is entering the system will be equal to the energy which is leaving the system. Same energy will be leaving the system along with the work extraction. Now we will divide throughout by the mass flow rate. Now when we divide throughout by mass flow rate, we get the equation as H1 plus V1 square by 2 plus GZ1 plus Q. Now this Q is the specific heat. As I told you, we are going to divide throughout by mass flow rate. So this term becomes Q dot upon M dot. Now Q dot upon M dot, while cancelling we get Q, and which will be equal to, the unit of this will be in kilojoule per kg. This is the specific heat. Similarly, this is the specific work in terms of kilojoule per kg. Now rearranging this, we get Q is equal to H2 minus H1 plus V2 square minus V1 square by 2 plus G Z2 minus Z1 plus W. Now this equation in the differential form we can write it as dq is equal to dH plus vdV plus gdz plus dW. This equation I have written in the differential form. Now this is one of the equation. Now from the first law we know that dq is equal to du plus pdV. Similarly, enthalpy dH is equal to du plus pdV. This, on opening the bracket, I get du plus pdV plus vdp. So this two equation I have got. This two equation I will substitute in the above equation. Now if I substitute in the above equation, dq is nothing but du plus pdV and dH is nothing but du plus pdV plus vdp. Now on substituting I get du plus pdV, this which will be equal to dq, and du plus pdV plus vdp, this equation which is nothing but equal to dH, and plus dW. Now the vdp and gdz, which is the change in kinetic energy and potential energy, we are neglecting it because the velocity at the entering and leaving the system is considered to be same. So we neglect the change in kinetic energy and the potential energy. So on neglecting we get the equation in this form. Now the common terms you can remove from both the sides, and the final we get it as dW is equal to minus vdP, or we can write it as work done from 1 to 2 is equal to minus integral of vdP. So from this we understood in a flow device work done is vdP. So if we plot it on graph in the PV diagram, so that means if you have an expansion process in a PV coordinate, you project the curve to the y-axis. So this area represents the VDP work, and this much work we get during the expansion process. Or if it is a compressor, this VDP work must be done on the compressor. Hope you understood. Work done in a closed system is pdV work, and work done in an open system is VDP work. So thank you for watching. Hope your concept of pdV work and VDP work is clear by this video. Thank you for watching the video.